So now we are finally ready to start talking about the unit circle. We're going to discuss the unit circle definition of the trigonometric function. So even though 7.3 is titled the unit circle, we've done a lot of 7.3 before we've even talked about the unit circle. And now we're going to plunge into that discussion. So let's talk about the unit circle definition of the trigonometric functions. So from now on, we will usually work with a circle of radius 1 centered at 0, 0, and that's called the unit circle. Let theta be an angle in standard position. Let xy denote the point of intersection of the terminal side of theta with the unit circle. So the unit circle has equation x squared plus y squared equals 1. And so what does this mean as far as the trig functions are concerned? Now we still can apply our formulas from earlier in this section. So let's see exactly what we can say. We can say that sine theta is equal to y over r, but that's y over 1, or just y on the unit circle. Cosine theta is equal to x over r, or x over 1, which is just x on the unit circle. Now what that means is if sine theta is y and cosine theta is x, this point with coordinates x, y is the same as, we could just say the coordinates are cosine theta comma sine theta. The x coordinate is cosine, the y coordinate is sine. So we have a much simpler description of sine and cosine here. As far as tangent is concerned, tangent theta, still y over x. That doesn't get simpler in this discussion. And so let's try to sum things up here. Now I got too much written around there. Also, I'm going to start writing cosine theta first, because we want to always make that connection with the x-coordinate. Cosine theta is x. Sine theta is y. Tangent theta is still y over x. And notice how with the unit circle that matches up exactly with that other description of tangent as being sine theta divided by cosine theta. And we also have secant theta, which is 1 over the cosine, so that's 1 over x. We have cosecant theta, which is 1 over the sine, is 1 over y. And cotangent theta, which is the reciprocal of tangent, so that's going to be x over y. And I guess I want to put all this in a box, because that's the crucial information. Now we're going to focus on the unit circle. We want to think of the trig functions as being defined just in terms of x and y here. And keep in mind that it really all depends on sine and cosine, right? So my more simplified version of things is on this yellow card, a new yellow card, where really we just want to see an angle theta in standard position. This point of intersection with the unit circle is x coordinate cosine theta, y coordinate sine theta, and that's it. And this, by the way, is our third step. So this is step 3 of our development of the trigonometric functions. right, now I'd also like to do a couple exercises before we finish this video, just a couple quick exercises. And here we go. So exercise 8, find x and y as pictured. This is a unit circle. So this point of intersection with the unit circle with coordinates x and y, well, if that angle, theta, is pi over 6, then that x coordinate is going to be the cosine of pi over 6. And the cosine of pi over 6 is square root of 3 over 2, which we have memorized. Y is the sine of pi over 6. And the sine of pi over 6 is 1/2. So x is square root of 3 over 2. Y is 1/2. In exercise 9, find x and y as pictured. Slight variation on things here. We want to find this coordinate x, this coordinate y, which is where the terminal side of negative 3 pi over 4 intersects the unit circle. And so we can say x is equal to cosine of negative 3 pi over 4. And y is equal to the sine of negative 3 pi over 4. But now here we got to be careful to, since we're in a quadrant other than quadrant 1, we got to make sure we get our signs correct. The reference angle is going to be, if this is negative 3 pi over 4, that's pi over 4. Because negative 4 pi over 4 would be negative pi. So we have a reference angle of pi over 4, and we know we're in quadrant 3. So let's see what we can say here. Cosine of negative 3 pi over 4 is going to be related to cosine of pi over 4, the reference angle. Since we're in quadrant 3, where both coordinates are negative, we know we got to take minus cosine of pi over 4. And for sine, it's going to be the same, right? Because we're working from sine pi over 4, but the y coordinates are negative. So I have to take minus sign on the sine. X coordinates negative mean cosine's negative. Y coordinates negative mean sine's negative. And both of these are values we have memorized. So I have negative square root of 2 over 2, negative square root of 2 over 2. So x is equal to negative square root of 2 over 2. Y is equal to negative square root of 2 over 2 in exercise 9. And I think there something just occurred to me. I'm going to go back to just put back on the screen our unit circle picture. It's probably good to end the video with that. And I just wanted to make sure everybody could see that on this picture, this radius r, in any position the radius is drawn, it's equal to 1. The radius of the unit circle is 1, so we were able to plug r equals 1 into our earlier formulas to get the new formulas for the trig functions based on the unit circle.